So good day everyone, I hope you are all doing well. So today I want to take you through limits involving absolute value function. So you will recall that the absolute value of x is given by a composite function. It will be x if x is greater or equals to 0. It will be negative x if x is less than 0. So that's how we define the absolute value function of x. So today I want to take you several problems of limits involving absolute value function. So let's do some few problems and see how we do them. So now let's find the limit, or let's determine the limit, or let's evaluate the limit as x approaches infinity, x minus 5 all divided by the absolute value of 3 minus 2x. Now let's look at this problem. We know that the absolute value of 3 minus 2x is given by 3 minus 2x if 3 minus 2x is greater or equals to 0. So, and it will be negative 3 minus 2x if 3 minus 2x is less than 0. So when we solve this, if we solve these guys, if we solve these guys, 3 minus 2x greater or equals to 0, this will be 3 greater or equals to 2x, then 3 over 2 greater or equals to x. So therefore, if 3 over 2 is greater or equals to x, that means x is less or equal 3 over 2, and 3 minus 2x is less than 0, 3 is less than 2x. If we divide by 2, 3 over 2 is less than x, therefore x is greater than 3 over 2. So similarly, we can write absolute value of 3 minus 2x as it will be 3 minus 2x if x is less or equal 3 over 2, and it will be negative 3 minus 2x if x is greater than 3 over 2. So, but what are we looking for? We're looking for the limit as x approaches positive infinity. It means that x tends to what? To bigger positive numbers. It means that we need positive numbers. So that means the absolute value of 3 minus 2x will be negative into 3 minus 2x in this particular problem, because x is approaching positive numbers, and here in this case x is greater than 3 over 2 is also approaching positive numbers. So it means that the limit as x approaches infinity of x minus 5 all divided by absolute value of 3 minus 2x is equals to the limit as x approaches infinity of x minus 5 all divided by negative into 3 minus 2x. So this will be just equals to the limit as x approaches infinity. This will be x minus 5. When you distribute negative, it will be 2x minus 3. So here we're going to use a theorem. There's a theorem which says the limit as x approaches or plus or minus infinity of 1 over x to the power r is 0 if r is greater than 0. So if the power or the index is greater than 0. So this is the theorem that we're going to make use of. So take note of that, take screenshot of that. So now continuing, this will just be equals to, we will divide by the what? We will divide by the power with the highest index in the denominator. So this will be the limit as x approaches infinity. This will just be x over x minus 5 over x all divided by 2x over x minus 3 over x. This will just be equals to limit as x approaches infinity 1 minus, this will be 5 over x, all divided by 2 minus 3 over x. So we use limit laws. The limit of a constant is 1, this one is 0, the limit of this one is 0, this one is 2, this one is 0 by that theorem. So this will just be equals to 1 minus 0, it's 1, 2 minus 0 is 2, then the answer is just a 1 over 2. So let's look at the other example. So we have this a nice example. Let's look at the limit as x approaches negative infinity of 2 plus absolute value of 2x plus 1 all divided by 2x plus 1. So we are implementing the same procedure here. So let's start first defining the absolute value function. So the absolute value of 2x plus 1, it will be 2x plus 1 if 2x plus 1 is greater or equal to 0, negative 2x plus 1 if 2x plus 1 is less than 0. So when you solve that into simpler form, this will be 2x plus 1 greater or equals to 0. So this will be 2x greater or equals to minus 1. Then x is greater or equals to negative 1 over 2. So and 2x plus 1 less than 0. Then 2x less than minus 1. Then x less than minus 1 over 2. So that's what we're talking about. It means that the absolute value of 2x plus 1 is equals to 2x plus 1 if x is greater or equals to minus 1 over 2, and it will be negative 2x plus 1 if x is less than negative 1 over 2. Negative 1 over 2. But what are we looking for? We're looking for the limit as x approaches negative infinity. They're approaching negative values. It means x should be less than minus 1 over 2. So this is the part that we are choosing. So therefore the limit as x approaches negative infinity of 2 plus absolute value of 2x plus 1 all divided by 2x plus 1, it will just be equal to the limit as x approaches negative infinity of 2 then plus negative 2x plus 1 all divided by 2x plus 1. So this will just be equal to, so this will be the limit as x approaches negative infinity of 2 then minus 2x minus 1 all divided by 2x plus 1. So this will just be limit as x approaches negative infinity of minus 2x then plus 1 over 2x then plus 1. So we'll do the same. We'll divide by the power with the highest index in the denominator, which will be just negative 2x all divided by x plus 1 over x all divided by 2x over x then plus 1 over x. So this will just be equal to the limit as x approaches negative infinity, then this will be negative 2 plus 1 over x all divided by 2 plus 1 over x. So this will just be equal to, so this will be minus 2 plus the limit of this 1 over x will be 0 as x approaches negative infinity. This will be 2, then the limit of that one will be 0. This is just equals to negative 2 over 2, which is just equal to negative 1.